Chapter 12, Fat-Soluble Vitamins, Screencast 5. This is the final screencast for Chapter 12, Fat-Soluble Vitamins. The next chapter, 13, will be focusing on water-soluble vitamins. The last fat-soluble vitamin that we will be talking about is vitamin K. It is broken up in two separate families. One is phytoquinones. This is known as vitamin K1, and this is found in plants, and that is the main biologically active form. The second type are manoquinones, vitamin K2. These are found in fish oils and meats, but also produced by bacteria in the large intestine. Now, when we look at vitamin K sources, 10% absorbed daily comes from bacterial synthesis within the colon. The rest is coming from food. Green leafy vegetables, broccoli, peas, green beans, vegetable oils, and keep in mind that it is stable to heat processing but can be destroyed by light. If we look at this image overall, really good sources, which are over the adequate intake for men and women, are Brussels sprouts, turnip greens, spinach, kale, and that would be a half cup amount of all of those. 80% of dietary vitamin K is going to be absorbed and incorporated into chylomicrons. Manoquinones that are synthesized by bacteria are absorbed by passive diffusion, and they will be incorporated into lipoproteins for transportation. The primary form of excretion for vitamin K is in bile. Now, the most important function of vitamin K is clotting. The image that we see here is breaking down the clotting process. And remember, there are two ways to get to the common pathway. You have the intrinsic pathway versus the extrinsic pathway, and vitamin K is actually necessary for both. When we look at where it plays the most role, it's the synthesis of blood clotting factors and the conversion of pre-prothrombin to prothrombin, an active blood clotting factor. Also, it does play a role in bone metabolism. Now, there is potential for the toxicity and deficiency of vitamin K. So let's first look at deficiencies. This is something that can occur in newborns, and this is because stores are low and bacteria is not yet present in their colon. All newborns are given a vitamin K injection at birth. Otherwise, vitamin K deficiencies are rare, but they could occur in prolonged use of antibiotics or someone that has impaired fat absorption. This would result in poor clot formation and hemorrhaging. Too much vitamin A and E negatively affect the actions of vitamin K. When we look at toxicity, no upper limit is set. Storage in liver and bones is limited. It is much more readily excreted than other fat-soluble vitamins, and injections of menadione can cause hemolytic anemia, excess bilirubin, and death in newborns. This particular diagram here is one that I talked about in the very first screencast, and this is a summary of the fat-soluble vitamins. Here we basically have a table that talks about all of the major fat-soluble vitamins, so A, D, E, and K. It talks about their functions, symptoms that are associated with deficiency and toxicity, identifies people that are at risk for these issues, and also good sources. So keep in mind, this is where I will go for asking questions as far as what are good sources of these vitamins, and that is important for any exam covering fat-soluble vitamins. Now, the end of this chapter talks about dietary supplements and are they helpful or harmful. Now, most Americans fail to meet dietary guidelines for fruit, vegetables, and whole grain intakes, and so we may have an inadequate intake of micronutrients due to those deficiencies. There is not enough support evidence to support supplementation, though many people will take them. Here, the best way always to actually get our required nutrients are fruit and diet. We can do this by consuming foods that are rich in vitamins and minerals, consuming foods that are fortified, possible multivitamin and mineral supplements, and also, in a very rare case, supplements that are individual. These are probably the ones that will have the most risk for toxicity, especially fat-soluble vitamins. Now, the Dietary Supplement Health and Education Act defines a supplement as a product that contains one or more vitamins, minerals, amino acids, herbs, botanicals, plant extracts, or any combination of the above. The thing to keep in mind here is the FDA does not closely monitor dietary supplements. Now, manufacturers can make structure or functional claims and unproven claims regarding conditions other than diseases. The quality, purity, and consistency, once again, are not closely monitored by the FDA. There is a designation, the U.S. Pharmacopoeia, USP, may be listed on products that meet established standards for dietary supplements.